this lesson, we're going to be talking about inverse functions. So an inverse function is found by exchanging the x and the y in the functions. Right? So when you take a function and switch all the x's with all the y's, that function then becomes an inverse function. Right? You can tell if a function has an inverse by using a horizontal line test. So remember, horizontal line goes side to side. So if you graph a function and there's nowhere on that function that will cross a horizontal line 2 times, then that function does have an inverse function. Right? Not everything does, but this is one way to figure it out. So we're mostly concerned about is finding the inverse function. So we're going to work on that first. So we're going to start with these two examples. So remember, f of x is the same thing as a y. What you want to do is everywhere you see a y, you want to write an x. Everywhere an x, you want to write a y. So this function would become x equals y minus 2 to the 5th plus 3. You just switch all the x's and y's around. Now what you want to do is you want to solve for y, right? So now that we've switched the letters, we want to take this equation here and solve it for y. So we want to move everything over here to the other side so that y is by itself. Right? So we're going to always start away from the y. So this plus 3 we're going to start with. The opposite of plus 3 is to minus 3. Right, we move the 3 over. Now we want to move the exponent here. And the opposite of an exponent is a root function. Since the exponent is a 5, we're going to take the 5th root of both sides. Right, take the 5th root of both sides. So if this was a 4, we'd take the 4th root. If it was a 3, we'd take the 3rd root. If it was a 2, we'd take the square root. Whatever exponent it is here, put that number on your root. Right? So we can't simplify the 5th root of x minus 3, but over here, the 5th root cancels the exponent out. So on the right side, we're left with y minus 2. The only thing left is to move that positive 2, or negative 2. So we'll do that by adding 2 to both sides. Over here, since this is a root, I can't stick it in the root for no reason. So it's going to have to stay outside of the root on the end there. Right? And now that the y is by itself, our final answer, we'll always write f, put a little apostrophe on it. That means prime, f prime of x. You see this? This means it is the inverse. So that little apostrophe just telling you that that's an inverse. And that's the final answer. Right? So switch the x and the y, solve for y. So in example 2, first I'm going to switch the x's and the y's. Then I start solving for y. So first I'm going to multiply both sides by 2. And then 2x equals, right, because the 2's would cancel. Now I'm going to subtract the 4 from both sides. 2x minus 4 equals the negative cubed root of 4y. I'm going to move that negative first, so divide by negative 1. Negative 2x plus 4 equals the cubed root of 4y. When you're trying to get rid of a root, you take both sides to the exponent of whatever number is here. So this was a little 3, so we take both sides to the third. So we're going to leave this here. That cancels our root out. We're left with 4y. Divided by 4 on both sides. So h prime of x is this. There you go. I'll do a couple more examples. So remember, first, switch your x and your y's. We'll multiply both sides by 2. 2x equals 5y minus 15. Add 15 to both sides. 2x plus 15 equals 5y. Divide both sides by 5. 2x plus 15 over 5 will equal y, which means that is the final answer. One more. So we'll switch our x and our y's. First thing to do to solve is to add the 1 to both sides. So x plus 1 equals y cubed. So I'm going to cube root both sides. I get the cubed root of x plus 1 equal to y. So g prime of x is the cubed root of x plus 1. There you go. One more thing we're going to talk about is if you're given two equations and asked, are they inverses or are they not inverses, what you do is you find both compositions, so f of g and g of f, so both directions. If they both equal x, then it is an inverse. Right? They have to both equal x to be an inverse. So I'm going to do two examples for you. So here's our first. So first find f of g, then find g of f. So f of g, we're going to put g into f. So this will go into there. So negative 4, negative 1/4 x plus 2 plus 8. Right. So we distribute the negative 4. That'll actually cancel out. So x minus 8 plus 8 gives us x. So that one worked. Now we're going to put f into g. So this time this one will go over here. So a negative 4 times negative 4x plus 8 plus 2. Distribute. A negative 4 and a 4 would cancel. So we get x. Negative 4 times 8 would be negative 2 plus 2 would be x. So these are inverses. And one more example. So first plug the f into the g. So 2 half x minus 7 plus 14 would be 1x minus 14 plus 14. That one worked. Now plug this one over there. So 1/2 2x plus 14 minus 7. X plus 7 minus 7 would be x. So these are also inverses. So they both came out to be x. Okay. If you need any help, please let me know on Remind or come to office hours.